This is BMS training for manning apartments. Present is I'm Tom Olson with Zenergy, and also
Vanessa Lee Rento with Cambridge Housing.
Alright, so this is basically just the video walkthrough of the graphics and for the BMS system. The BMS is accessible basically everywhere, outside the building or inside the building at this address, https://50.252.217.18. I guess sometimes when you put it into certain browsers it thinks you're trying to search for something, but 217.18. Okay, that's good. The first time you ever log in on a browser, it's going to give you this page that says this site is not secure. Basically all it means is that the browser doesn't like the certificate that we're using. We're just using a default certificate from the software so that the HTTPS, the secure connection to the server, would be verified from the browser. The browser would recognize the certificate and basically say, alright, yeah, this is a trusted host. All this is saying is it doesn't know that this host, so it can't say that it's trusted, but we are saying that it is. So all you have to do is really just try and bypass this message the first time. So if you hit details, this is Microsoft Edge. If you hit details and you go onto the web page, it'll bring you onto the login page. What we typically like set up for people on their computers is to just use Firefox for the BMS if they don't already use it, and you can set the login page to be your home screen, just so every time it comes in, it loads up, it directly comes right to the BMS, and it's just easier to get to. So I think the home page here is set to Firefox Home. I'm going to change it to the current page. So now if we hit the home button, it'll bring us right to the login page, so it's just easier to do. So I set up this account just for this training session, so it's training, password in. So what you're seeing here is the basic interface for the BMS. So on every page, you're going to see this title at the top, Frank J. Manning Apartment, that's a building, and some sort of title and description here. So this is the home page. You're always going to see the date and the time, the outside air temperature and humidity, and a little product placement for us. And if you ever have issues with the BMS, you're looking at a graphic and you have questions, and you either want to, whether we're still under warranty or service contract down the road, screenshots are sometimes the easiest and most effective tools to describe what you're seeing right now. So rather than tell us, hey, the space temp's off and all this, that, and the other, if you see an issue, take a screenshot of the whole screen and including the date and the time and the outside air temp, and that'll just help try and determine what's going on. Personally, I like in Windows, it has a built-in snipping tool. It's really easy to use. I actually usually just pin it to my bar down here, so it's always available. So I pinned the taskbar, so anytime I need it, I just hit a screenshot, you hit a new, and you drag and drop. Now I have a picture of that going on. So, maybe I just took a screenshot of the cogen not running because it hasn't run for some reason for the past month and a half at least, which I believe T-Cogen is coming on site to look at some point in the next couple of weeks. So you're always going to have these links at the top here. Tries to operate just like any website would. Your major systems at the top, your heating and your hydronic systems, the 2 ERVs providing fresh air to the apartments, alarms page, schedule page, the user's backup, and drawings. I actually just added this. It's just a link to our control drawings. So if you allow pop-ups here, this can be a useful tool if you're trying to figure out how things are supposed to work. It's just a PDF version of our control drawings it takes a second to load, to download, but then, if you're on your own personal computer or something, maybe download this and have it available to you so you can bring it up anytime you want. So these are, just a scrollable version of our control drawings. So if you ever had a question about a sequence or something and you didn't have the printed out versions directly accessible. These are here for you. So we'll exit out of that. You also have floor plans for each floor. On every graphic you should see this. So if we had an issue with the 9th floor, we go to floor 9, room 909, 906. They complained it was a little warm. So the navigation, once you start to use it, gets pretty. We'll go over that in a second, but the actual graphics navigation, once you start to get used to it, it's pretty user friendly. Other things available to you are on the left here. There's this little circle button here. This is basically the overall navigation of the system. So these are pretty much all of the graphic pages available. Some people prefer to use this tree format rather than links on a page, but it's whatever really works best for you. Importantly, over here is how you will view all the histories and the trends. They're broken up. We'll go over this at a later part, but they're broken up by equipment and zones. So try to make it easy to find all of the trends that are available for troubleshooting. So we go back home. So what you're seeing here, all these graphics are being hosted by basically a computer down in the basement on the ground floor in the old water heater room where the booster pumps are for the hot water. That's where Zenergy's main control panels are. Black box that we refer to as a JACE. It's a form of a JACE. The manufacturer and the product is Tritium Niagara. So this is all a Niagara-based system, pretty standard. This is currently N4, so it is, I think, a couple years ago they released this new version, which has all HTML5 graphics and some updated security features. Just updated the version to 4.6, which it was licensed for, so that's currently what we're running. Just a really user-friendly interface and everything. But basically, these graphics are being hosted. It's a web page that's being hosted in the basement on that black box. So that box needs to be running at all times. There are some lights on it. There's the 2 Ethernet ports. One is the local controls network, and one is the public internet provided by CHA, which is how we're accessing it here. Those have 2 indicator lights on them that should pretty much always be flashing. There's also a power light to the left. Lights should be on in order it's functioning. If lights aren't on, then obviously the power is off or something. That whole control panel is powered off of a UPS, so if for whatever reason the power gets shut off, UPS will keep it running for hopefully as long as until the emergency generator kicks on. This site is never supposed to be down. There's some global programming that's going on. Not much, just kind of some monitoring the programming that the system is responsible for. Otherwise, all of the programming for everything is done at a local level. So if all the communication went down, if for whatever reason wires get cut or what have you, all the controllers will handle their system locally, even if there's no communication to other things. So that's kind of the whole part of the design. You put controllers out in the field that can control their own system and then communicate them to all of them in order to monitor them and do sort of global programming on a building-wide or larger system-wide scale. Downstairs there's also a row of routers. They are STP to backnet IP routers. All the controllers in the building are wired to a 2-wire MSDP bus, and those are all wired back to those routers in the basement. There are roughly 10 of them, maybe 12 total, I think. All of those lights need to be flashing at all times in order for the communication to keep to stay up. Those little routers are roughly the size of like a an iPhone, round and a little thicker, twice the thickness of that. All those need to be powered and operating. If you ever have an issue, I'll go over this in a little bit as far as communication or troubleshooting communication issues, but that's always a place to look down in that basement, making sure all those lights are on and everything seems happy down there. Basic navigation in the system. All of these pick buttons will take you are links to other pages. So let's look at the heating water system. So this is a link here. Hopefully it'll load. Here is the entire heating water system minus the snow melt, which is another hyperlink to a different graphic. Writable points are typically italicized here, and you can hover over them and they outline. If you notice here, there's a little outline. You can right click on them in order to change, try to write to that point. When an override has been put in, that is when you'll get this purple background here. So the purple background says, if you hover over it, notice you have the status that it's overridden. Hovering over any point, it'll tell you, the name of that point in the system and what its present value is, and also the status. So this point is okay. There's nothing really to report about this point. It's just normal. This point, it's purple because it's overridden. At 8 just means it's at priority 8. It's just a priority scheme as far as writing to points, and a manual override just comes through at priority 8. Different colors that you may see, background colors. Purple is overridden. Red means something is an alarm. So if you notice down here, we have a couple boilers that are an alarm. If you have a red background, that means it's actively an alarm. If we go to, there's a few other background colors that we can view. So if we go to room 1203, I know we don't have communication to this one, so orange or yellow, they're a little different. Effectively, they're basically the same thing. It just means that we've lost communication to that controller. So if you hover over these points, see that it says that it's down. So that means this controller is not communicating. So it's down as far as communication. That is a yellow color. The orange color, which is pretty much the same thing, it just means that the point is at fault. So that means that the system tried to do something, write to a point or read, and it ran into some sort of error, whether it timed out or it just wasn't able to write for some reason. It'll turn orange, and that is a fault. So, but effectively they're the same thing. It's some sort of communication issue. I'm not sure if we have any faults active system-wide, just because I had restarted the system earlier, and I think a lot of those faults cleared. But typically, say in a room, a controller, we're writing to a controller, and then someone turns off the controller loses power. Someone switched off the disconnect. We lose power to the controller. It goes down, but we're trying to write to a point, but now we can't write to that point. So that's what a fault would be. Basically, if you go to any page and you see a bunch of yellows or oranges, we are not communicating with that controller, the BMS. So that needs to get troubleshooted. So is it just an issue with that one controller, or is it an issue with power? If you lose the power to the whole building or a complete section of the building, or did the communication wires get cut? So, that's basically what that yellow or orange is trying to tell you, that we've lost communication and the system just isn't communicating to that controller anymore. Then how the networks, kind of along those lines, you might have network issues at some point. I know a few times through construction, we've experienced some issues with the networks because of wires getting cut, or just through construction, everything, the things changing and affecting the controllers. The way these networks are run for all these rooms are up the stack of rooms. So all of the networks in room 12 for each floor are on the same network. So it just runs up, hit room 12 on every floor. And actually, it hits 2 stacks for one network, so it actually goes up 12 and maybe back down 10. Off the top of my head, I'm not really sure specifically how each network is run. Basically, if you see, if you come to this one room and you see that 1203 is down, you go to floor 11, and we see that 1103 is not down. It's communicating. We see that on floor 13. 1303 is communicating. Now we know we just have an issue with room 12. But if we saw that the same room on every single floor had an issue, well, now we know there probably is an issue with that network. So either a wire got cut, or one of the communicating thermostats damaged and are affecting the network, or there's a power loss down at the main control panel, or the entire network lost power. So you can kind of just use these colors as a way to troubleshoot, the background color, to troubleshoot what's going on if you have a communication issue. That's pretty much the only background colors you'll see. if the system is trying to load point, you'll see a gray background. I don't know if we go to a page, which we'll run into that. If we go to the chilled water system. But if it's gray, basically the system is trying to go and ask for that point value, and it's just waiting to get it. That's called stale. So it just means we haven't read that point in a while, so we can't verify the validity of the value. But we're trying to go and re-pull the point. And if something stays too stale for too long, then it'll most likely go into fault because we had a communication error. Stale doesn't necessarily mean an error; it just means that we haven't talked with that controller in a while. You notice we have a lot of overrides currently in, and that's just because we're doing the water balancing. So all of the valves in the building should be open so that we have full flow through all the coils, so we can verify the design for the flows for both heating and cooling. So you'll just see that as we're clicking around that things are over and open and off, and not normal operation. And also these boilers went to alarm. But other colors are the actual point color. So green means that is a point that we are communicating with the controller. We're going out, we're asking the controller for its value of that point, and then it sends that point back to the BMS. So green just means this point is actually residing out in a remote controller. So there's we're going out, asking that controller, hey, what is your average water heater temperature? And then it responds back with this value, and so we're just trying to signify that with the green color. That color will change. The only other time you'll see a different color for points is like on floor plans. You notice the warmer rooms are red. If they were, I believe it's currently set to 78 and above, which is honestly kind of high. I think I'll change that to 80 and above. A lot of tenants like the space. Typically we do like 78 and 65 or 68, depending on what the customer wants when they're on their floor plans. But it's really intended just to, as you're clicking through the floor plans, to draw your attention to rooms that might not be operating properly, you might have an issue with. You're going to find out if there's an issue in a room pretty quickly if someone's in there and it's hot or cold. So that's usually the best test for whether things aren't running. But also clicking through the floor plans and seeing these red or blue colors. If it's too cold, it'll turn blue. But like I said, I'm going to change these so that anything above 80 is red and anything below, 65 is blue. Because like I said, some people like it really cold. A couple people like it really cold in their room, and most people like it pretty warm. So those are the three colors you'll see. You'll see green, red, or blue as far as the actual point color. And for background color, you'll see nothing, which is good, or red, which is an alarm, purple, which is overridden, and then yellow and orange means that there's a communication issue.